Welcome to Exponential Chats, provided to you by Exponential Ventures. In this week's episode, we'll be talking about the promises that 3D printers would allow us to print our own products from the comfort of our home in a more sustainable way, and why that isn't a reality yet. My name is Adriano Marques. I'm the founder and CEO of Exponential Ventures, and today I have here with me Nathan Martins, Harlei Vicente, and Rhuan Silva. Before we start our discussion, let's briefly set the stage here. 3D printing is not a new idea. In 1971, the first patent was issued to the concept of a device called the liquid metal recorder, which operates in a similar way that an inkjet printer would, but operating in 3 axes and using remelted metal instead of ink. It wasn't until the 1980s before we saw the first operational 3D printers in a new round of patents issued in the field. Due to its extremely high cost and complexity, 3D printers remained unpopular for decades until in 2009, the patents for fused deposition modeling 3D printing expired and the industry began to flourish, and low-cost 3D printer manufacturers flooded the industry with promises of a future in which we'll be able to 3D print our own products from the comfort of our homes in a sustainable and affordable way. The idea is that a household with a 3D printer would be able to purchase the 3D model of a product and reproduce it on demand and at a low cost. Although this is already true for some products, 3D printing has yet to become mainstream and still can't reproduce most of the important products that we need and use on a daily basis. What is it that needs to happen in order for 3D printers to fulfill the promises of a more sustainable future in which everyone will be able to reproduce the products they need on demand at a low cost and from the comfort of their own homes? Let's start by talking about what these products look like and how they're manufactured. Nathan, when you think of 3D printing promises, what products did you wish you could 3D print from home?
I guess some of the first products that come to mind are like the plasticky things that I have on my desk, like phone holders and headphone holders and decorations, those kinds of things, but also in a more hobby kind of sense, like 3D model rockets and those kinds of stuff, like Nerf gun modifications, because I bought a Nerf gun recently. It's been a lot of fun. But mostly, yeah, those kinds of stuff. What about the rest of you guys?
I think that for me, it will be all about Arduino boards. I think it will be the first thing I would plan to print because it's kind of a hobby to me, and I think it's a good idea to use 3D printing for that. It's great. I have already saw some projects on it. But I also like the part of furniture too.
Well, to me, I personally would love to be able to print electronics in general, because that's the most expensive stuff that technically, if you were able to print, you'd get the most benefit out of it. But also, anything along the lines of furniture would be great as well, especially being able to print out a wood-like material. That would be pretty amazing.
That is actually possible already, and you can do that with fairly simple. The most common 3D printers, the FDM 3D printers, and it's not totally wood. It's actually a composite of wood with a PLA plastic. That's the most common form, and they essentially grind the wood into a powder and mix that with the plastic. And then you put it through the 3D printer and it prints something that looks like wood, but doesn't have the grains and the knots. It just looks like wood. And to some extent, it also behaves like wood. So you can stain it. And, if you do a little sanding, it can definitely look like something that was made out of wood, even though it has a high percentage of plastic in it.
Well, did not know that. That's very amazing. That's actually incredible. You could technically print out any furniture then, in a sense, as long as you had the proper printer. Is it similar to the resin type printer where you mix the different compounds?
Well, the resin type is using a technique that we call the SLA, stereolithography. And the way it works is you have the liquid, the resin, on top of an LCD screen that projects each layer in ultraviolet light, and that layer hardens the resin. And then you have a base that is inverted. Instead of the bed being faced up, it's actually facing down. And then it keeps pulling the model as it imprints the next layer using ultraviolet light. That one is really just resin. You cannot mix, I think, wood there, because that would compromise the integrity of the resin. That's actually something that would be interesting to test. But the one that I'm mentioning is the FDM. And the FDM is the one that you buy the filament, and the filament goes through the printer and into the hot end that we call the extruder. And then it melts the plastic and deposits on top of a printing bed. And this one is facing up. So you go layer
Yeah, so
by
most
layer.
of them are switched, like, right? FDM prints from the bottom up and SLA prints from the bottom down, right?
Yes. And then you just, with FDMs, you just come and you deposit the plastic on the printing bed, layer by layer, and then when you get to the end, your print is over. But it's essentially just hardened plastic comes in, melts near the extrusion point. It's extruded where it needs to be extruded. Then it hardens immediately because it's exposed to ambient temperatures. And you keep doing that, and at the end, there is no post-processing that needs to be done, other than just perhaps sending if you care. But for the most part, it's just a ready-to-use piece that you take off and you use. When it comes to SLA, for the most part, when you're using resins, you want to harden it further by exposing to more ultraviolet light once the model is ready. And also, because you take it off the tank, you also want to clean it up. So there is a mandatory pre-processing that is a lot more involving than FDM. Anyway,
so besides FDM and SLA, there are a couple of other ones that, while researching, I found out. One of them is selective laser sintering, which, from my understanding, is just, I've seen a guy do this with sand. But basically, you just create a powder material. In his case, you use sand, and then you roll it on the building platform, and then you keep fusing it and then putting on another layer. So basically, this guy put sand and then put a huge magnifying glass and took it out to the desert, and he would build stuff using sand. Besides that, we also have SLM, which is the same thing as the other one, but with metal. So you basically fuse the pieces of metal together. That one was really cool. And then the last one that I saw was binder jetting, which takes material in powder form as well, and then just glues it together. And then you have to actually put it in a kennel for it to fuse and figure everything out. Besides those, are there any other more methods?
Well, there is some other ways of 3D printing that are specific to their own realms. So you have the 3D printing industry for foods, for tissue, for civil engineering, and then for each one of them, you have different methodologies that vary slightly, but the concept is always the same, in which you have essentially 3 axes, and you have the deposition of material that is going to form the model, and you work layer by layer. The ones that you mentioned that uses either light or laser, those are actually very interesting in that they can do stuff that no other manufacturing process can, not even FDM 3D printers. And here's why. When you have the powder on your printing bed, and this powder is going to be whatever, it can be nylon, can be ABS, can be PLA, it can be metal. You have this powder, this bed of powder on top of your printer, and then you sinter or you melt the first layer, then you bring another layer in. You always have a layer of material that the next layer can sit on top, regardless of whether or not there is material underneath that's going to be part of the metal. So you can essentially have like a ball that has a ball inside, and another ball, and another ball, and another ball. And then once it's done, you just shake the powder off, and now you have something that couldn't have been put together by using any other technique. and can only be done with laser and with SLS or SLM techniques. It's really powerful. That's actually the technique that Elon Musk is using to produce rocket engines, because by doing this, you can reduce the number of moving parts, you can improve reliability, you can strengthen the parts that needs to be strengthened, and you save materials. And those materials are the metal used for those rocket engines are very expensive and hard to deal with. So I heard that Harlei wanted to do electronics. You know that, if you had the plans and the parts, you could do electronics at home using a cousin of 3D printers called CNC machines. Have you heard about them?
Yeah, I heard about them. I'm assuming that they're the horizontal surface, and then whatever you can do in a 2D sense, it'll just go there and cut out the parts that you don't want, but in a single plane. Is that the one you're talking about?
They also operate in a 3-axis, so you can actually have depth into the cuts that you make in the material. But with a CNC machine, for the most part, you're removing material out of something you're not putting in. So you have a router on a gantry that can operate X, Y, and Z, and you have your material. You identify the origin that you assume to be the origin, and then it comes and removes material from it. So if you have this sheet of aluminum, for example, you can actually make a 3D carving on this aluminum or wood using a CNC machine. It doesn't need to be all 2D.
But it does have the limitation of not being able to make, for example, a ball, right? Like if you were to make a sphere, I don't think that technique wouldn't work, because you wouldn't be able to get underneath the...
Yeah, so with CNC machines, it gets a lot more involving, because if you want to do a ball, then you would put a cube, you would do the top part, and then you would have to flip it over, re-identify the origin, and do the other bottom.
Oh, okay.
But it's possible. It is possible. It's just a lot more work, more margin for errors. If you don't recenter the object in the right place, then your ball may be off a little bit. So that's one of the challenges of CNC machines. But say that you had a CNC machine and a 3D printer, and you had the components, the electrical components, all of the transistors, the resistors, the red fires, anything that you would need to build your electronic. You could essentially just put a circuit board there. It would cut the holes for you to put the components and solder afterwards, and it would also leave the channels so power can go from one component to the other on your board. And then you can take it off, you can put the components, solder everything, 3D print the housing, and then now you have your electronic. But as you guessed, this is yet not fulfilling the promises of 3D printing, because it's not mainstream. I mean, I could do it, you could do it, but we're hackers. We can figure this kind of stuff very easily, but that's not the average person out there.
So you can actually, make a custom board, like, and route wires that are not there yet. You just get the PCB and then make your own connections on top of it. I didn't know you could do that.
Yeah, the circuit board, when you buy it virgin, it's just a laminate of fiber in the middle and copper on one side or copper on both sides. It just depends on how you want to do it. And then you make the design of the board, considering the size of the circuit board you have, and you put it on the CNC. So the CNC is going to remove the copper from the top to make the communication channels, or the path in which the energy is going to go through from one component to the next. And the fiber in the middle works as an insulator. And it's also going to put in the holes on the right places, so you can come with your components and have their legs go through the board so you can solder them from the other side. And then if you're using double layer, then you would just flip it over, complete the other side, and then put in the components, solder them, and it would work. So that's essentially how you get to do that with CNC. It's not super hard, but it takes practice to understand what you're doing and doing it right. It's not something that you would expect someone to just go to a hardware store or an electronics store, buying a CNC machine, and all of a sudden they're building their own TVs, their own headsets, or whatever they need. At the end of the day, that was actually a good example of the TV. You end up with components that are very hard to acquire, and you cannot possibly build it yourself. So you end up having to rely on a distribution line that's going to provide you with the screen. It's going to provide you with some other components that you're not going to have laying around in your home. So that's one of the problems with 3D printing, really, is that it's not the answer to all the problems we have. You can fulfill the dreams of Nathan. He said phone holder, baby Yoda, whatever plastic trinket and novelties that you want to play with, Raspberry Pi case, Arduino case, and boards that Rhuan mentioned. You can do all of these stuff, and it's fairly easy. But when it gets complex and you have to deal with other materials that cannot be 3D printed, then that's when you get into trouble. And you have to rely on a distribution channel. You have to go buy those parts from another distributor. You still have to purchase them. You still have to wait for them to be delivered. Or you have to, hop in your car and drive down the road and find a place where they provide you with that. And if you're doing that, then why not just go and buy the real thing? Why go through the trouble of 3D printing everything? I mean, I understand that as a hacker, but for the average person, that's not a reality.
But what about the bioprinting? When you need to print, like on the medicine area, you need to print some human body part and like to do a surgery, I don't know. And what kind of materials do you use there? And I think it's worth it to print something than wait till something has a part to donate to you, because it's really hard to find it out.
3D printers, they're actually used very often in medicine and orthodontics. If you use resins, you can reproduce tooth. You can make bases for remaking parts of your dental structure. You can make molds for all sorts of braces and things that you use, but that's not really something that goes inside of you. Then you get into medicine, where they're using 3D scanners and tomography to get, for example, the shape of your hip. And now you have the femur. You can reproduce the base of your femur where it meets your hip. And you do that with titanium. So you use SLM to reproduce this part. And now you have a surgery where you put titanium inside that person. So this is actually being used very successfully. I've seen also a case in which it was used as a filling for deformations. I think it was someone that had either an accident or an attack in which part of the jawline was destructed, and then they 3D printed to reconstruct, put in place, and then close it back, and it was not rejected by the body. So there is definitely use for 3D printers. You can achieve a high level of precision if you're mating this part with a piece of bone that has been fragmented or is otherwise fragile, or that you want this precise fitting to that person. Not everybody's bones is the same size, same thickness, same shape. It's all approximate. So you don't want to get a piece off the shelf that was designed for someone who's 6'5" and you're 5'3", right? And that's not going to work for you, or vice versa. So with 3D printing, you can actually do that one piece, one time, that is specifically made for you, and it's going to work perfectly. There is nothing else that you can get out there that's going to be better than that, other than your original part that you lost. So that's very nice. And then finally, there's this frontier of medicine and 3D printing, where doctors and researchers, they're trying to 3D print organs using the actual tissue. And that one is a bigger challenge. They've managed to do smaller prototypes, such as small arteries, and you can see that arteries, they're covered with a lot of muscle. And you see that they would contract, they would hold some blood. But as far as building a whole functioning organ and transplanting that into a person, that in that case would actually be implanting, not transplanting, but implanting that into a person. I have not heard of that yet, but that's the ultimate goal. Because then if you could do that, you can essentially eliminate some of the pressure that happens when it comes to transplants. If I can just take a piece of my tissue from my heart or from my skin or my marrow, and I can reproduce cells and rebuild my own heart, that's the perfect solution, because now I have a heart that's not going to be rejected. That's a heart that is exactly the same that I had when I was healthy, and I don't need a donor. I can go with it after, I don't know, a few days of cultivation in a lab. Once the heart is ready, it just implants into me, and now it's ready to go, brand new. So it's also better in a sense, because it's a heart that was never used. So I'm getting 0 miles on this heart, whereas if you're getting a transplant, is whatever miles that other person lived with it, right? So,
Well,
go ahead.
there's a problem with that though. If you actually print the exact same heart with the same muscle, assuming we manage to print muscle layers, fat layers, blood vessels, and everything intertwined, and it's supposedly the same, well, your heart oftentimes, from a DNA perspective, it comes with, you may have a heart disease situation in the way your heart's built. So that's also going to come back again. So in a sense, you're going to get the same problem maybe 10 years from now.
Well,
so it's literally, it will have everything.
That's interesting. Let's think about this. So the way that our original heart is built is out of your DNA expressions, and in your mother's womb. That's when your heart is first created, and then it evolves from there, also respecting this DNA expression. It's going to follow all of the instructions that your DNA expresses in producing the proteins that's going to produce the fibers in the exact place, the exact form. But, you could also develop heart diseases because of conditions that you lived through. Perhaps because of drugs that your mother used, or perhaps because of just different chemicals that you've been exposed to. And none of that are determined by your DNA. Now, if I'm taking some of your tissue, say from your marrow, and I'm reproducing cells for muscles, for arteries, for fat, to rebuild your heart, and say that you had a faulty valve, I can actually build a perfect valve out of your tissue. And it's going to be 100% you with your DNA, but it wasn't created through the expressions of your DNA. So in a sense, say that your DNA is faulty, that the fibers that it generates is going to be faulty. Then I guess in that case, yes, you would still have a faulty heart. But unless it's something that can be fixed physically by recreating and using this material to rebuild a new heart, then no, you would not have a problem. You would have a perfectly working heart. And then you can think of cases where you would do a preventive replacement of your heart. Someone does a check and say, hey, your heart is okay. You're probably going to live another 40 years, but you know what? I think that we should schedule a surgery to implant a new one in the next 6 months. Your insurance is going to cover it, and it's going to extend your life at least another 60 or 70 years.
So that if we were to get to that point, I'm certain that there would be a market where people are selling upgraded hearts that have no heart diseases at all. They're guaranteed for 100 years, and that would be, well, hopefully that's far off into the future. That's a little too much for me personally, but
Yeah, you get into points where now you're improving. Now you're an athlete, and you want to improve your VO2 max. So let's get a bigger heart or a leaner heart, or a heart with a bigger cavity or with stronger muscles. I don't know what combination you need as an athlete, but I can think of ways that you would try to hack the system by getting yourself a new heart, and nobody would be aware of what happened. And now you're competing at a very high level with a heart that nobody else can have naturally.
well, when it comes to stuff that's happening already, I've read an article where researchers were able to print a human-like ear, baby-sized human ear, and they attached it to a rat so that the blood from the rat would keep it alive, and
Right.
and that
That's
actually happened. Yeah, and I heard about this recently, and I'm not sure if they actually printed the tissue or how exactly they did it. If they literally layered the skin cells, but there was a rat in the lab and it had an ear attached to it, and they were happy about it.
Right. I remember that it was grown in lab, and because it's cartilage, it's not unheard of. It's just that it is a fairly complex piece of cartilage with skin attached to it. So it's and the veins and arteries, so it's kept alive. But it's not like a heart, right? So I'm not sure if it was 3D printed, but it is definitely a very good step towards getting that kind of replacement.
In this case, I believe they either used, I think they used 3D printing for a part of this process. I think it was to print out the cartilage, and they actually layered skin cells over it, so it grew, attaching itself, following kind of like how our skin follows the bones and everything, except it was 3D printed, I believe.
Got it. Okay. So yeah, we're definitely walking towards that kind of technology. Hopefully, it's going to be there soon. It's going to be able to help a lot of people, but there are definitely concerns, ethical concerns, on how it's going to be used. And one of them is the case of athlete trying to improve their performance by getting a better heart or a better lung or better muscles. So we may end up in an era where if this is allowed, then there is not going to be an end to how many improvements you're going to try to pursue in order to get that edge and compete.
Well, nowadays we have something that's already similar to that. When it comes to swimming, for example, competition, they've started creating new types of suits that literally will make you like 1 to 2% faster, something along those lines. Not sure about the number. And it started getting, people started creating laws and defining regulations for how they can be done. Even more recently, I think there was a shoe from Nike. They created a shoe that made people actually faster in average. That was like a noticeable 0.5%. And that shoe, if I'm not mistaken, was banned from competitions for a while, or this year or last year. And I think much like that, we're going to have a situation where it's going to go along that direction.
Yeah, I think it was the shoe that Nike designed to beat the 2-hour mark in marathons, right? They wanted to do under 2-hour marathons using this shoe.
I believe that was it.
Yeah. Those I'm not sure if they qualify. I have a hard time thinking about this, because there are definitely shoes that you could use to run that's going to degrade your performance more than 1 or 2%. And those are allowed. There is no standard on what kind of shoes you would wear in order to run a marathon. In fact, you can run a marathon without any shoes if your foot is thick enough. But you're trying to put a limit to that. Essentially, you're trying to put a limit to how much we can improve the sport, and say that this shoe is so much better that really you can run a sub 2-hour marathon. Then why not? If this is one of the evolutions in the field, then why not allow it? Why not expect other shoemakers to come up with improvements on top of that, and come with even better shoes than those? So I don't think those are cheating, unless it's something that it's like putting weights, or artificially trying to give people an edge, as opposed to by design giving people an edge. That's my opinion. What do you guys think?
Well, I agree with you as well. I think if it should be, if you can do it, you should be able to go ahead and make it and let people use it. But now today, I know there are regulations about the suit they make for swimming, and I think well, in a sense as well, they're not allowed to use certain types of drugs that enhance the performance. And I think that would, or a 3D printed heart that could improve your breathing, your oxygen delivery by 15% would be something completely that one person would alone be able to outrun everyone for sure. And then, I mean, let's assume that's actually very expensive to do, and it would be the day that did happen. Whatever country does it would have an edge, and the other countries that are not able to invest that much money would be behind. But I'm stretching a little bit here, but yeah, that's my opinion about that.
I'm no sports expert, but I think at the very least you could create a separate division for those kinds of improvements. Call it freestyle or open competition, where people can come up with their own improvements to compete. And it's intended, those kinds of competitions, they're intended to extend the limits of the sport. So for shooting, for example, you have these open competitions where you can use all sorts of contraptions to improve your reloading, improving your aiming, improving your precision, improving your repetitions. And those are not allowed in the other divisions, but you can come up with those at an open division. And if they're good enough, they're going to move the sport further. And, who knows, maybe in the future, that's something that is so commonly used that now becomes the standard. So I think that it's important to give athletes the opportunity to compete, not just on a physical level, but also on the intellectual and creative level, trying to do different things in the sport to extend the edge and make it that much better, make it that much more evolved when compared to what the standard is without any accessories.
Giving my 2 cents, I think we're deviating a bit from the topic, but we already have, I think we skipped over a couple of important points in that sense. Whereas not just because we're able to print these organs doesn't mean they're easily switched. Like having a heart surgery is a big thing that can risk your whole life. Having any organ switched out is a really big surgery. And I don't see advancements in 3D printing automatically equalizing success in those other fields, because surgeries are difficult, not just because the human body is difficult, but because we're subject to chance. Things can just go wrong and we have no control over that. So I don't think an athlete would do that just to have a competitive edge. I think he would if he were truly desperate, but I don't think, like, if you have a healthy heart, you wouldn't go out and switch for one that was like exactly the same. Unless you were to switch out, like now we're talking about augmenting the body. So if I made a heart that was 3 times bigger so that I could run longer, or eyes that had like super bionics or something like that, because we already have stuff like that. Like if I'm a person and I have a heart transfusion, like I change out my heart, I can still become an athlete. Like no, and if I win, nobody's gonna be like, oh, it's because Nathan had a surgery 5 years ago and changed out his heart, he can't compete with us. Like we already have people who do that. That's not an issue.
Well, so I think that people would do it. People would undertake the risk of surgery for improvements, and we see that as normal today. So
But
women
you
would
can't
undergo
guarantee an
surgery
improvement
to
like
enlarge
that.
their breast. they would undergo surgery to improve lines and traces of their face or remove some fat. So that people are willing to go and do the bariatric surgery. Those are, in some cases, they're actual.
They typically don't do it like for their work. Like it's typically like, unless you're a model and you're doing something for your face, you actually work with your face. If you're doing what you mentioned, which is like the stomach one, that typically is the case for somebody that has poor quality in life. Like they're not able to do exercise, or not able to move around. They don't feel comfortable. So that's not merely because of their job. Like, you know what I mean? Like if you're an athlete, your job is running. So you're doing a surgery because of your job. Whereas those others that you mentioned, those are more like life improvements. Like I'm a programmer. I read all day. I did surgery on my eyes to stop using glasses. Does that mean that, you know?
I guess because, I mean, if you do surgery in your eyes, then your vision is not going to be any better than someone that has perfect vision. And if you do a transplant of your heart because you had a disease, then your heart is probably not going to be any better than any other player, any other athlete competing in the divisions or in the sport that you compete. So I think those are okay because of that. We're talking about something else. It's like having a super heart. It's like having
So it's augmentation. Okay.
Absolutely. Yeah.
One thing when it comes, that's a little bit of biohacking in a sense. Well, that brings some, like, just like if you get a car and you want to make it faster, you can go, it's installed turbo on it. If you turbo the car and that's not properly set up, the other parts of the car might not be able to withstand all that pressure. So if let's assume 3D printing gets to the point where we're able to do something like that, and you set up a heart that's 5% higher blood throughput, and you do that, most certainly the other parts of your body might take a hit and not be able to handle all the additional load, which happens when you turbo a car. For example, if the car is not properly prepared, it was not constructed for that additional horsepower in a sense.
I think that the only part of the body I would ever try to replace it's my liver, because I think I will reach a day in my life that I will need a new liver, and I think I will actually mess up with the new one too, as I'm messing up with
I have a question for you guys. Do you guys believe that we'll actually reach a point where we're able to print multi-material things such as Can you guys hear me okay? I'm getting some echo.
Yeah, there's some echo.
Yeah, no.
You can try to mute, please.
So you guys think we'll be able to reach a point where instead of, because nowadays we can do 3D printing of single material very well. As far as I know, we can also do print more than one material in a single run, I believe. Correct me if I'm mistaken. Do you guys believe we'll be able to print multiple materials within a single go? And that, in turn, in a potential future, that's what we'll need to achieve to print organs successfully in a TV, for example. How far are we from it in you guys' opinions, or are we not going to get there at all?
You can 3D print with multiple materials already. That's a possibility. There are various different techniques, from just changing the composition of the filament as it comes in, and you kind of like have just-in-time technique, where the part of the filament that's coming in is exactly the one that you need printed at that time. But there's also this other more primitive technique where you have just different extrusion heads with different materials, and then you come and you make a layer with that material, then you pull out that extrusion head and you bring the other one with the material you want. So you could, in essence, have a piece of equipment that is made out of multiple plastics or combination of plastic and metal, even in one. So it is possible. It's just not common that you would purchase a 3D printer like this. and have that kind of material available, unless you're really trying for that kind of solution.
So, but that's actually that's already doable. We can actually print something like that today.
Yes. So at our office, we have, I think, 12 3D printers. One of them has dual printing heads. And one thing that I like to do with that one is whenever I have to print supports, I would print the support using PVA, which is a plastic that can be dissolved in water. So you use PVA, and then you print with ABS or PLA, which are plastics that are not dissolvable in water. And for those prints where you have an overhang, and you would need something in there in order to print so the plastic would not fall down, you actually put PVA underneath coming from the bed, from the printing bed, all the way to where you need it. And then you would come in with the layers of the other plastic. Once you're done, you take this huge piece, dunk it in water, and now the whole PVA is out, and you end up with a piece of material that is exactly what you wanted, but would otherwise be hard to do with just one piece of material, just one plastic. And if you did with only one plastic, then your post-processing would be a little bit more complex. But it's something that we do, to just have your support done with the same material. But this is just one example that I'm trying to give you, that if you have, for example, supports inside an object, so you're printing the ball, for example, and you want to print support inside the ball, you wouldn't be able to reach inside and carve out the support. So if you use PVA, then you can just dunk this ball in water. Water is going to come in, is going to dissolve the material, and the material is going to come out. Now you're left with the ball that is the exact shape that you wanted and doesn't have any extra materials that are unwanted inside of it. You can also do that with material that you want to be a part of it. So say you want to print support that is for Nathan's phone that is black and white. In one extruder, you put black, the other one you put white, and now you have those heads working in tandem to create the design that you want with a combination of those shoe collars. So you don't need to do any pre-processing and paint them manually. It is already possible. It's just something that requires more work and understanding on the part of the operator in order to make that happen. And if we're talking about, for example, a 3D printer that's going to come with a casing and then the electronics and then finalize everything, then that's on a whole new level. I'm not sure if that's the kind of 3D printing that you're talking about.
Or in a sense, yeah, I was imagining if that were to happen, because in a sense, the way I see it, that would need to be a normal thing. That would have to be a daily printing situation for us to reach a point where we're printing a full TV. And in a sense, the impression that I've got from 3D printing, nowadays it's used for prototyping. You create a mold for an action figure, stuff like that. And in a sense, it's more of a prototyping technique. And I question if it would ever replace the classic traditional methods that we use in the industry today: extrusion, injection molding, and all the daily techniques that are used to create things that we use every day. And they're actually very cheap. Would 3D ever manage to be cheaper than those things? Because in a sense, it's much more complicated. An extrusion, you pretty much have a material being pushed through, and you can do that very quickly, very precisely, and get good quality. When it comes to 3D printing, you've got a whole lot of electronics. And my question to you guys is, will 3D printing ever replace those, or will it always be this niche prototyping strategy that's in some scenarios the only solution, but for everyday things, just a prototyping tool? And that's how I see it, at least.
You guys want to go ahead and comment on that one? I'll go then. So, I'm not sure. I'm not sure if we're going to get to that point. But today, it is already cheaper to 3D print than to purchase a product. And it works kind of like this. For you to do a handful of things, it's much cheaper to do that with a 3D printer. If, on the other hand, you're a manufacturing and you need to put out thousands of the same product, then it's cheaper to go with traditional manufacturing processes. Because even though you have a much bigger overhead, a much bigger investment up front, the cost per part, per piece, it's going to be much lower, and the output's going to be much faster. So your profit's going to be larger. If you're trying to print phone supports for people's desk, and you're trying to use 3D printers for that, during the time that it takes to print one, traditional molding technique would print hundreds, 1,000, and for much cheaper. So for us as individuals, if we're just producing something to solve a specific problem, yes, it is cheaper than just going out there and buying that, hopping in your car, go through the risk of driving, get out on the store, purchase that product, which is going to come with the wrapping and all of the profit that is expected from everybody in between the manufacturer and the grocery or the store that you went to purchase this product. You can skip all of that and just print with plastic. No wrappings, no waste, and you have the product that you want. So
I don't know.
It is cheaper. It is cheaper, and can give you custom fitting that is not possible with other products.
I think from my perspective, the price analysis, it takes into consideration a couple of more things. So it depends really where you're from. Like in the US, 3D printing is a lot cheaper than it is in my country, Brazil. If I went out to buy things, I think I would spend about 3 times more than you guys would. And the other perspective that you mentioned in the cost analysis is also our labor, because not just the machines and the plastics, but also how much time did this take me as a person to figure out how this works. If I'm a tech person, it will be relatively cheap because I already know a lot of stuff. But if I'm someone like my mom or my neighbors, they probably don't know anything about this. It'll probably take them 2 or 3 weeks. And that's, if we were to add that up, it would be pretty expensive.
You're right. So a 3D printer is not so cheap that everybody would consider buying it without really knowing what they're doing and really knowing what they're going to be printing with. We have 3D printers here ranging from $300 all the way to $2,000 to $3,000, depending on the quality and the printing bed size. But the same way that we don't go around driving our cars thinking of how expensive it was, we just drive and we consider that the cost that we have of this car is kind of fixed. We're either paying for it or we paid in the past, and we get the benefits out of it by just putting gas and oil and giving it maintenance and paying the taxes or whatever we have in terms of expenses, insurance that we have with that vehicle. But some of these we don't even take into account when we're driving out. So insurance, for example, you're going to be paying whether or not you go out. Taxes you're going to be paying whether or not you're going out. So what we really consider when we're driving long distances or when we're driving on a day-to-day basis to go purchase products is really the gas. So in a sense, if you go ahead and you believe in a 3D printer, 3D printing future, and you purchase a 3D printer, after that, you're going to be considering only the cost of plastic to print your stuff. Because you acquired that good that provides you the long-term benefit of creating other things just by adding more plastic. See what I'm saying? It's kind of, I know you're right. You're right. And making that decision, I'm going to buy a 3D printer. I'm going to have this 3D printer at home. It's a big leap. Most people buy 3D printers and they never use it because they never figured out how to use it. And they try a few times and it just becomes a mess because they couldn't fine tune it. They couldn't level trim the printing bed. They mistreated the filament, and now the filament it's not working very well. The quality is poor, and they just give up. But assume that you know, and it's easy enough, and you have this 3D printer. Next time that you're printing something, even your phone base, you're not going to be thinking, oh, I spent $1,000 in this printer, so this is going to be a very expensive phone base.
Let me make a separate analogy to that. Just imagine that you could make food. Actually, we don't have to imagine. Everybody typically has a little bit of space in their house where we could create a little garden and plant food for ourselves. Why don't most people plant food, and why do they prefer going to the grocery store? Because most people don't have time. I'm pretty sure 3D printing takes a significant amount of time to get right. There's also variety. I'm not sure all 3D printers will accept all types of plastics, that kind of stuff. But what if I want something made in ABS and I don't have ABS? My machine won't work with ABS. I have to go out and buy another one. So looking at from that angle, from an analogy to food, I won't plant every single type of crop because one, I don't know how, and two, it's not cost effective. If I plant a piece of corn, it'll give me 2 to 3 pieces of corn, and that's it. If I wanted enough corn for my family, I had to plant a significant amount. I don't know. That's just kind of a point. There are people that love gardening and they do it and they eat most of the stuff that they do, and they work to create bigger gardens and more food and that kind of stuff. But there are people who are I'll just buy from a store.
Yeah, but even people who do gardening, they do groceries because they cannot grow everything that they need year round. So I get where you're coming from, and luckily for 3D printers, if we're talking about plastic and we're talking about FDM printers, there's a wide range of plastic that you're able to 3D print without doing any changes to your printer. The biggest considerations being just the temperature range of your hot end in the extruder and whether or not your printing bed is heated or not. So those are kind of the elements that you have to take into consideration when buying a 3D printer, at least an FDM 3D printer, to make sure that you can work with a very wide range of plastics. So you can work with nylon, PVA, PVC, PLA, ABS. What's the other one that we do with Apache with bottles? There is a variety of plastics that all of them, you just buy them and they're going to go into that printer. TPU, TPE, those are flexible rubbery plastics that we can also put through those printers. But really think about it. If you had a 3D printer, you would be thinking about plastic going forward. You would not be thinking about the price of the 3D printer anymore. And that's why I think it's kind of like an investment that you make, same way that you do with your car, same way that you do with your computer, same way that we do on a daily basis with a TV and stuff that is as expensive, sometimes more expensive. And sometimes you don't get any financial benefit out of it. A TV is more expensive than a 3D printer, and it's not producing anything for you. You're not going to get
producing entertainment. You're using it every day.
That's fair, but you could have that on your phone. You could have that on your computer.
Not at the same scale. No, I wouldn't agree with you. If I wanted to watch a movie, I would have to go out and buy one ticket, go to the movie theater. Watching it on my phone isn't very comparable to watching it on a TV or movie screen.
The point of the TV is that it doesn't have the monopoly of entertainment, whereas car has the monopoly on transportation if you want to be independent, and a 3D printer would have a monopoly on creating things if you want to be sustainable at this point. And you could definitely just reuse, recycle. You can create your own stuff. You can carve with your own hands a piece of wood, and you can do many things without ever having a 3D printer if you're handy and if you really have the intent. But what I'm trying to say is that with a 3D printer, you expand your capabilities. It's an investment that you make, and now you have something that anytime you need to produce something to solve a problem, you go ahead and do it. I had several instances in my life where, because I had a 3D printer, I could solve it. So one example, the servers that we have, some of the prototypes that we built for our cluster, they were overheating, and I noticed that the airflow was not appropriate. The chassis that we purchased and the layout of the boards and the graphic cards, they were not ideal. So in order to improve the airflow, I built an exhaust that would come from behind and suck air from inside the machine right in the direction where I wanted the air to come from. And it would exhaust towards the AC return. So that was perfect because I would now have all this hot air going straight to the return, cold air coming and being sucked from the front. And that would not be in the way of my cables because I had extensions alongside with that exhaust. Some other cases, you can have just needs that if you go out there, you're not going to find someone to solve them because they're very specific to you. You broke something in your home, and now you want a replacement. If you know how to do 3D modeling, you can 3D model and print. For our office, for example, I did the design of the coasters that we use around the office, and we 3D printed them. You can do hangers. So you want a very specific hanger for towels, for anything that you want. You can 3D print them because you're not going to find them there. And you want this very specific design that you think is ideal for your decoration. So you get some of that benefit that there is no money that's going to afford that to you. True.
I think, in a sense, Nathan's right when it comes to the fact that for an everyday person, getting to print something is more than just buying the printer, is understanding how it works and everything. But I believe in general, as time goes on, it'll reach a point where all you need is download a model. Doesn't even have to be 3D prepared, let's say, because I'm aware there's a bit of a process you got to do. There might be a point where an app will automatically prepare any 3D model. It can maybe scan something with the scanner that with the LiDAR coming into new phones, you scan something that's converted into a 3D printable model, and next thing you know, all you really need is a printer. So once that happens, which I don't think is very far away, we'll be able to literally scan and print something. And we kind of have the technology that's coming in with the LiDAR and everything.
I kind of see this as a kind of a tech-centric kind of view, because we've been 3D printers for a couple of centuries now as humans. Like there's woodworking, there's masonry, there's all kinds of things that we can learn, and that has really gotten lost in the past few years. Like not a lot of people know how to use wood like they used to, like our grandparents used to. So like if your door or your chair got broken, they would fix it. They wouldn't go out and buy something they would have to fix. There wasn't anyone that sold anything. But today, with the whole commodity and globalism and everything, you can just order it off Amazon and then you're done. I think in that sense, that's something that'll never go away. If someone is inclined to do manual work, they won't need a 3D printer. Because like things around the house, most of the time you can make it. I think a good example of this is Cuba. If you take a look at their maker culture, because of their huge embargo that they had, they can't buy things. So a lot of the things that they have, they just recycle. Like they take something that used to be for something and they build it into something else. They reuse everything that they do. So I get it, what you guys are saying, but like in the sense, there are alternatives as well to just 3D printing.
Yes. No, you're absolutely right. It's really a balance of possibilities, of time, of cost, and skills. It takes the skills to use a 3D printer effectively to create 3D models. I'm not saying that those are equivalent to woodworking, better or worse. Those are different skills. And for someone that loves woodworking, I would recommend them just, buy a 3D printer because your woodworking abilities are going to increase a lot because you're going to be able to. And I have a friend that's been working a lot with woodworking recently. But you can look online. You can build a bunch of tools for woodworking using 3D printers and to do stuff that you cannot really do. I think that one thing does not substitute the other. I think that it is awesome for you to develop as many skills as you can. But but there is something to having the ability to just download something from the internet and having your problem solved without having to break a sweat. There is a price to that. There is a value. And hopefully that's something that we're going to start having in our homes sooner and at a higher quality and at a cheaper price. So I think we have one question here from Igor. Igor is from our team. Yes, in the future, everyone will have a 3D printer at home and print small things needed on a daily basis. Or is that not the objective of this market? The idea really is that if everybody had a 3D printer at home, now you have the ability to sell 3D models for solving different kinds of problems. And some of these 3D models, they are actually customizable. You can define certain features to that model that is going to fit your specific needs. So in a sense, it's better even than trying to purchase a product, because you may not have the exact size and features that you're looking for when you're purchasing. But the idea really is that if people have 3D printers in their homes, then you have a huge market that you can tap into to sell 3D models digitally online, so people can download them and print the products that you created. Today, if you have a 3D printer and you want to print something, but you don't have the ability to design the 3D model, there are free marketplaces such as thingiverse.com, where you can go and browse a huge library of 3D models that you can download for free and 3D print in your printer. There's way too many things that I have print there, throughout the years. It's a great community, and you're gonna find essentially everything. If you're looking for solving Nathan's problem of having a stand for his phone, you're gonna find hundreds of different designs for a phone stand. Designs where you can leave your charger on, designs where you can put one of those wireless chargers, designs that are just decorative, all sorts of designs with Star Wars, with you name it. You're gonna be able to just look at it, see the ones that you like, download, 3D print right away, and you have it. So yes, the idea is that if we had 3D printers in our homes now, we're going to be able to 3D print on a daily basis, as long as we have a need on a daily basis. So with that, we're almost 3 minutes past the hour. I'd like to thank you guys very much for the participation, for all those watching and leaving comments. We really appreciate that. Next week, we're going to have, again, another Exponential Chats. We're going to be putting on our blog the topic for the next conversation. And soon, I'm going to be uploading this audio to our podcast as well. Thank you very much. See you guys.